For the final lesson in this chapter, we're going to learn about solving absolute value inequalities. We have solved absolute value equalities previously. Now we're going to work on inequalities. These are our objectives. If a is a positive number, then the absolute value that is less than a is equivalent to negative a, less than x, less than a. That look familiar? Doesn't that look like the compact form of an inequality that is an intersection or an and? You can also find this chart on page 100 in your textbook. So we're going to solve the absolute value of x plus 4 when it is less than 6. So whenever we have a less than, we can put it in compact form. We're going to subtract 4 from both sides. So our answer, it does not include negative 10 and does not include 2, so it falls between those two. That's why we have the parentheses when we're writing it in interval notation. This one's a little more complex. We need to isolate the absolute value symbol first, so we're going to subtract 6 from both sides. Set it up for the positive and negative. It's less than, so it goes in compact form. We're going to add 3 to both sides. So x does include 2, and it does include 4. It falls between 2 and 4. This one is again a less than. We've got a problem. There is no solution because it cannot be less than a negative number since it cannot be negative. Absolute value is always how far it is from 0. Remember, it cannot be negative. So this one has no solution. That only happens when you have the negative symbol. This can be found on the chart on page 102 when we're talking about greater than now. If a is a positive number, then the absolute value of x is greater than a, and it's equivalent to x is greater than a or x is less than negative a. We're talking about an or, so we're talking about a union now. Again, we're going to start by isolating the absolute value sign. That's the first thing we have to do. So we subtract 1 from both sides. Now set it up to the positive and negative. This time when you set it for positive and negative, you've got to reverse your symbols. So notice when the negative number, with the negative number, your inequality symbol is reversed. And then we're going to solve both equations by subtracting 10 from both sides and then dividing both sides by 3. So our answer is negative 11/3, or x is less than a negative 11/3, or it is greater than negative 3. So in interval notation, we go from negative infinity to negative 11/3, and then our union to negative 3 to positive infinity because it's greater than negative 3. Let's look at another example. Oh, well, it's greater than 0, so the solution is going to be all real numbers, since all absolute values are non-negative. So all real numbers is our answer on that one. Any value for x that we substitute into this inequality will give us a true statement. Let's solve this one. A little more complicated. We got a fraction, but still we're going to set it up when we set it up for the negative. Remember, we reverse the symbol, and the positive is kept the same. We are going to multiply both sides by 2 to get rid of our fraction. Subtract both sides by 7 on each side. So x is less than or equal to negative 15, or x is greater than 1. In interval notation, we go from negative infinity, which is not included, so parentheses. 15 is included, so a bracket. With a union, 1 is included to infinity because it's greater than 1. Now, what would the graph of the previous absolute value inequality look like? It'd be 2 separate disconnected pieces, one moving up from 1, the other moving down from a negative 15. If you look on page 104 in that chart, it'll also give you some more graphs and detailed information. That would be important to put into your notes. Very good. You're ready to begin practice.